All right. Hello, everyone, and welcome to Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to climate change. I'm Zach Semke, director of the Accelerator, and I'm super excited about today's construction tech episode featuring a passive modular case study. Today's co-hosts of Construction Tech are Ilka Cassidy, Mark Willey, Shannon Pendleton, and Sean St. Amour. And with that, Ilka, please take it away.
Awesome. Thanks, Zach. So welcome everyone to Passive House Accelerator Live's Construction Tech Edition, and happy Wednesday. So I'm Ilka Cassidy from Holzbaum System and Passive House Accelerator and Source 2050. And as Zach said, I'm here along with today's co-hosts, Sean, Mark, Kevin, and Shannon. So turn on your camera, rename yourself with your location, and open the chat, and maybe you'll meet someone new today. So that would be awesome. So I am also very excited about today's presentation, which is about a Phius-certified multifamily modular construction project. And I can promise that I will have so many questions. So I am also looking forward to seeing everyone at the Reimagine Building Decarb event on Friday. And I guess all the other conferences that are coming up in the next few weeks. So yeah, Sean, over to you.
Yeah, absolutely. Look, I love it. So yeah, I'm Sean St. Amour. My passion is resilient prefab passive houses. So today's presentation just screams fantastic, fabulous, and fun, and I can't wait to get started. But you're right, Ilka. It is a busy week for the Accelerator. We've got Reimagining Buildings, Decarb. So again, hopefully you've got it all in your calendars, because again, Reimagine Collective is also coming too. We'll talk more about that at the end of the show. But Mark, over to you, bud.
Well, nice to see all these lovely faces, wonderful backgrounds. My name is Mark Willey, and I'm so excited today because when you see the example of teamwork, you know that you too can do that with the people in your industry. So look for those little instances that will spur you on to take on your next challenge. Watch for the tools and the practices that they use. When you have questions, let us know. And as Shannon said, when you hear an acronym, be the first to tell us what it is. Over to you, Shannon.
Amazing. Thank you. I'm going to catch that. I saw that, Sean. Thank you. Great to be here with Ilka and my Passive House brothers. Today, I'm Shannon Pendleton. I lead Passive House projects at Sanderson Sustainable Design and Source 2050. Please reach out if you have a project to share. This is my favorite time of the week. And today is extra special because we have Mike Kirby from Signature Building Systems with us today. He's got over 25 years of experience. He's been in the modular industry since 1996. He is primarily in the engineering field. He's got several ICC certificates, and he is great to hang out with in the factory, in the field, and online. So I've had the pleasure of two of those. We haven't been in the field yet together, Mike, but I can dream. We also have Tony Lasanti with us today. His bio is on the Phius website, and I encourage you to check it out. It is one of the coolest bios I've read in a while. Here's the short story. He has a Master's of Science in Organizational Leadership, a Bachelor's in the Science of Mechanical Engineering, and an Associate's in Internal Combustion Engine Engineering Technology. So, he's a little slow, let him get some time to get up to speed. He's got 36 years of experience in MEP design. As a maintenance specialist, he's an account exec with Con Edison of New York, director of energy sales with Robinson Energy, and currently serves as managing director at Integral Building and Design, Inc. in Nyack, New York. So he has more than 3,000 dwelling units for the EPA Energy Star program and more than 1,000 for EPA Indoor Air Plus, and numerous zero energy ready homes, Phius Plus homes, and HERS ratings for IECC compliance. So please get your questions ready for the chat. I know that was long, but well earned. Gentlemen, thank you for coming today. We're very excited to have you. And Mike and Tony, take it away.
Thanks, Shannon. Super excited to be here. Thanks for having me. Yeah, so I work for Signature Building Systems, Director of Commercial Operations. And in 2019, we were approached with building a multifamily building. And oh, by the way, it had to be Phius approved. So, that threw a lot of unique challenges into our operation. We've never been through that process before. Oh, and by the way, I'm by no means an energy expert, but I can talk at least about the coordination that had to happen to make this project successful. So I can start my slideshow. All right, can everyone see my screen? Awesome, thank you. All right, so like I said, I'm from Signature Building Systems. We're located in Moosic, Pennsylvania, which is nestled between Wilkes-Barre and Scranton, right off Route 81. We've been in business for 30 plus years, and we work on a whole array of different type of product. We, we can work on anything from a 1,000 square foot ranch, 2 stories, to houses like this, very multi-story complex houses. We build about 50% single family and 50% multifamily. And here's just an example of, what a multifamily. This was a 4-story going over a podium. So this is a photo of our factory. I don't know how many people on here have ever been to a modular factory. They're all a little different, but they're all a little similar at the same time. So it truly is an assembly line. It starts off, by building a floor, and then it moves to another station, and then we're craning on exterior walls, and then we're moving it down the assembly line a little further, and then we're craning in ceiling assemblies. It's a pretty fascinating process to watch. Like I said, it's a very diverse product that we build. So you can come to the factory on a Monday and come on a Friday, and it could be something totally that's different and unique that goes online. One of the things I wanted to point about that's unique about modular construction is, if you can see here, we actually build from the inside out. So we're setting an exterior wall that has finished drywall per se, and then on the outside we are running wiring and plumbing. The exterior sheathing is one of the things we do at the tail end of the line.
Hey, Mike.
Yes.
Could you? I think that your mic is rubbing against your face a little bit. Yeah.
Oh,
yeah.
I'm sorry. Is that better?
Yes, it is. Thank you.
Okay, great. All right. So this would be the LaMora Senior Living project that was in Yonkers, New York. That's the project that we want to talk about today. This is a bit of the teamwork down here. That was who was all involved in this building, and here's what the building looked like at the end. Okay, so let's talk, I guess, a little bit about the pre-construction, right? So, this came to us as needing to meet the Phius standards. So one of the things we had to, talk about was the details, right? So, what type of details did we have to put into this? What type of exterior, wall sealing? What type of additional stuff that we typically don't do that we have to do for this job? And when it comes to, most of the factories, I'm going to say, don't have, a full-time energy expert for these jobs. So we're really relying on the designers and the architects to come up with details that apply. I'm going to back up for a second. So, our industry, we've been building to some pretty strict energy standards for years now. It all started with the air leakage that they defined in the IECC several years ago. We built a really tight product. We've had to deal with Massachusetts stretch codes and lead requirements. So we're accustomed to building really tight modular product, but now it's amped up a step, because now we're talking about Phius standards, and we weren't really sure how to handle them. So again, we're really relying on the energy designers and the architects to work with us. We have for instance, in the modular industry, we have a lot of fire assemblies that work well for modular. We have a lot of connection details that work well for modular. We have a lot of typical air sealing details that work for modular. But when it came to ramp up to Phius, that was kind of a challenge. So this is, if you can picture it this way, this is the floor plan of one of the floors for Yonkers, and this is just a visual aid on how you take a big building like Yonkers and you carve it up into different modules. So you can kind of see everything color coded is a different module length. And then you're really just stacking these modules in the field to make a big building. But there's challenges. There's CMU elevators, there's stairways. This was definitely a challenging building for sure. So one of the things we wanted to do was work with the architect on trying to demarcate, for all the disciplines on, what signature was providing and what was being provided in the field. So anything that you see shaded in the architectural details was what was being installed at the factory, and everything that was not shaded was going to be installed in the field, so we can delineate the scope. And then here you can see we started to develop some, the architect started to develop some air sealing details, so that we knew kind of what materials, how to apply them. All right, and then we started into fabrication. Okay, so then what the fabrication process was, I think at the end of the day, once we got past pre-construction, the feeling was that we had the details, we had the materials, we were going to go into fabrication, and then as we started the fabrication and got to a point that we were pretty far along, the plan was to invite the architect, to invite Tony's team down, to invite all the disciplines down to come and inspect the product to make sure that we were air sealing the way that we were supposed to. What was working, what wasn't working, what didn't we account for? Because there's a lot of different conditions in these buildings that it's hard until you go into production. It's just really hard to tell. So some of the challenges were like, how do you properly seal a media panel? Because as I think Tony cheerfully referred to this as like a box of Swiss cheese, because there's so many penetrations in a media panel, and this is something that in the past we really didn't have to deal with. So this was a learning experience for us. This was how do we properly partition this off and get it all sealed off so that we don't have any problems in the field. The other thing we did too is we had to assign roles in the company that just had to do with the air sealing or the Phius requirements that we never really had to do before. So for instance, this was a building with a flat roof, which means we didn't have a crew that had to worry about like shingling roofs. So we took the people that were shingling and then we made them the air sealers. And we worked hard with training them to make sure that there was everyone understood what the goals were. We also had someone who just did photo evidence of everything that we were doing, so that everything was documented. We had the QC department had a separate air sealing checklist. That was something new for them to have something like that, just an additional tool as we went on the assembly line. The other thing that we did is we also hired an independent energy professional who came to the factory every day, and he audited the process daily to make sure that everything was going according to the way that Tony and the architect were planning on having that.
Yeah, Mike, if I can chime in a little bit.
Certainly.
So because this was a Phius-certified project, it shouldn't be overlooked that there are really 4 different programs that the project needs to comply with. The first is the Energy Star Multifamily New Construction Program. The second is an Indoor Air Plus program, also by the EPA. And then the third is a DOE Zero Energy Ready Homes program, all three of which are prerequisites for Phius certification. So the in-factory, the sort of pre-drywall, pre-insulation inspections are all prerequisites for these programs. They're all required. And without a pair of eyes, a really good trained set of eyes in the factory, both on the part of Signature as well as their third-party verifier, this wouldn't have come out as good as it did. And it really needs to be mentioned. I just want to throw the name out there. Pete Vargo, who was the independent energy consultant, he's a Phius verifier and a rater, colleague of mine. I've known him for years. He just happened to be in the right place at the right time, or the wrong place at the wrong time, depending on how you want to look at it. And he was really instrumental in working with Mike and his team and the guys on the floor and getting the air sealing details right and getting the insulation quality right and helping out with the photo documentation so that we could satisfy all these prerequisite programs and be assured that when the boxes were delivered on site and handed over to their set crew and the general contractor, that things were going to go reasonably well. So.
Yeah, thank you, Tony. I appreciate that. Yeah, and like I said, so our industry, like Tony was saying, it's a very audited and regulated industry. We're constantly being inspected by a third-party agency, sometimes a state agency. We encourage, building inspectors to visit our plant. We're very proud of the product that we build. Up to this point, we had been building a really tight house. We've been, dealing with blower door testing now for quite some time. Vermont has some really unique energy requirements, so we build a lot to the state of Vermont. So it's a little unique because we have to adopt to whatever standard that we're building this building to, and there's several out there. Could vary per state. So that, yeah, this is just a picture of, some of the caulking that was being done. One of the other things we learned too, when we were trying to determine the amount of material for caulking per se, we learned that in these jobs, you can't look at the bottle of the caulk and say, you really need a 1/4-inch bead or whatever. It's going to be much more than what the bottle says it's going to be. And that's okay, but that's something we we had to pivot pretty quickly on that one.
Yeah, for sure. These are not machined metal parts, the mating surfaces. These are, it's a regular lumber, and as straight and as good as the lumber could be, it's still, there's gaps and seams and waviness, to where the boxes connect especially, but even within the factory. And so all these air sealing details, some of them were known, some of them came, as a little bit of a surprise. But it was really through the tenacity of Mike's guys and Peter working with them that they got the first couple of boxes right, and then tried to figure out a way to repeat it, down the line. So.
Yep. Thanks, Tony. Yeah. So this is just a photo of some more modules on the production floor. You can see they're starting to sand. This was, I think we just wanted to show like the level 1 installation. And again, we're accustomed to doing that. Sometimes even though we're accustomed doing it, sometimes it's not tied to a program like the Phius standards. But we have the other unique thing is, so we have a guy who insulates. I call him a little Picasso because I think he does such a great job, like, because we have some really unique, sections of framing that not everything is a perfect 16 inches on center. And I just think he does a great job with it. One of the other things though, is, what do you do when little Picasso is sick, right? Like, because the guy who jumps in for him always does as good a job as he does, right? No, that's not how life works, right? So when you have for the air sealing crew to be like the key crew, we had to, we had meetings daily, like who is here, who's not here. We have to make sure that whoever was sealing yesterday is doing just as good a job as they are today, because we knew that was crucial to the success of this job, which is a little atypical than what we're doing. this was a challenge too, is, we get to a roof module and it had open web trusses, and they're open web because there's ductwork that's going on the roof, and there's, penetrations and all sorts of stuff. So then we got to the end of the line, we're like, oh man, like how do we properly fill these voids in? So, we worked with Tony, and, we literally had to cut pieces of bat insulation and triangles and stuff to fit them in the open web so that we could then put the rest of the insulation in. And you're probably thinking, well, why don't you just do like loose filled or blown in? But, when you're getting into these jobs, the factories are pre-buying all these things in volume ahead of time. We didn't have any bat insulation or blown in insulation. And the production line does have to keep moving. So, we did the best of the situation that we could. Moving forward, I think when we're working on these jobs, I think we're pricing in like blown in or blown in or loose fill insulation, so we don't run into that problem, because it was very labor intensive to piece that insulation in. One of the things that would be helpful moving forward, and one of the things we learned is, the architect on their detail for the window flashing, it just said like approved, or it just said I don't know, like vapor tape or something, or air barrier tape. So I can tell you, like, what the factories think is an acceptable air barrier tape is not what you energy people think is an approved air barrier tape. So, we learned names like Resisto and Siga, things that were foreign to us. This was one of the things that we learned during the factory visit when, Tony was here, and the architect was like, oh, wait, I'm not sure that's the right type of tape you want to be using on your windows. So, that was definitely a learning experience.
Yeah, again, this is not, this is a municipal building, right? This is senior housing owned by the housing authority. So we were really concerned with, not just getting past the blower door test and the certification, right? We're really concerned about the longevity, the resiliency, long-term durability of the building. So we really pressed for, and fortunately, we're able to kind of win over the owners in approving things like this. It was in their own best interest to use the best quality that they could afford for things like air sealing the building, just so that, it doesn't come off in 5 years or 10 years. Okay.
Yep. And, it was a learning curve. It was a learning curve in a lot of respects. Yes, there were some gaps in the scope, and everyone kind of had to make some concessions. There was, there were some change orders, but at the end of the day, everyone was pulling the same direction. Everyone wanted the building to succeed. So, I really appreciate how pliable everyone was during this. All right, so then what we decided to do was, once we felt confident with what we were doing with the air sealing, well, we needed to see how these buildings tested, right? Because last thing we want to do is set, 92 plus modules out in the field, 4 stories tall, and find out that, oh man, you're going to have, a failure. How successful were we doing this? So, what we did is we wanted to do some blower door tests here at the factory. And it may sound that, that may sound like that's an easy process, but it's really not, because what you have to do is you have to take 2 modules, put them together as tight as possible. You have to seal up, all these penetrations, and the way the modular construction works, like this down here on the lower right is a floor access panel. And that's where there's a floor access panel in one module and a floor access panel in another module. This is where the two modules come together. So there's going to be some type of MEP connection going down under there. I think in this case, the electrical feed was going to the panel box on the other side or something like that. So, we had to go around and try to mimic field conditions and seal all the, and make sure that all these accesses were sealed. And let's see, there are some other pictures here. Yeah. So we also had a lot of what they affectionately called Smurf tubes, which is, just pathways for future alarm wires, low voltage wires. So, everything just had to be sealed really tight. and again, we had to bring the buildings together. It's a very labor intensive process. We had to do it on a Saturday and bring some people in because again, we can't stop the line from producing. So yeah, let's see if I have some more photos. Yeah,
some of the challenges, you know, Mike is right, because unlike a conventional stick-built building, where you might be able to do some QA, QC, airtightness, fog testing when the building shell is completed. In this particular case, Signature is sending completed boxes that have finishes on the interior. There's drywall, you know, a coat of primer, tape, cabinetry, doors are hung, light fixtures are installed, you know, other electrical fixtures are installed, plumbing fixtures. You don't have access to the exterior building envelope to chase air leaks the way you do in a conventionally framed building. So it was really important to sort of prove or to validate the air sealing, even if it was on a compartmentalization level at the factory. And in 20 years of doing ratings, you know, 20 plus years, I have never seen a modular factory do this. And I'm not saying that others haven't, but this is the first time I've seen a concerted effort to put two boxes together in a factory, put in some temporary air sealing measures for openings, and actually do an airtightness test. And if you go back to the plan that Mike showed earlier, each pair of modules, when they're married together, comprises two apartments. One apartment on one side of the building, one apartment on the other side of the building, and a chunk of corridor in the middle. So each green and purple stripe there, you know, that's two boxes. And what they did was they married the first two together, and then Peter did a blower door test on the entire assembly, and then on each apartment to check the compartmentalization, really to validate the air sealing efforts. And I had never seen that done, and the effort was well worth it because the results were great. So.
thank you, Tony. Yeah, plus, you know, and also, you know, we really wanted to stand by our product, right? Because, you know, we're responsible, you know, our scope was really responsible from, I'm going to say, the sill plate or the podium up, but there was some, you know, there was a considerable amount of work that had to be done in the field. And we wanted to make sure that, you know, our product was complying with the standards that, you know, everyone expected them to comply to. And I'm going to, you know, we did take it very seriously, you know, because we know what the effect would be if they failed. You know, again, to have a failure in a building this size would not be a good thing. So yeah, so, you know, we're literally joining, you know, one module here on the right and a module here on the left. We're trying to tape them. We're trying to mimic all the field conditions to get this the blower door testing done. And we did learn, you know, we started the blower door test, and then, you know, it wasn't quite where we wanted to be. So then, you know, they would bring, you know, like the smoke machine out, and we'd find out, oh, they didn't seal the range vent properly, or there was a conduit for where the major feed for the panel box is going to be. And there was just all these little things that we had to learn to seal, you know, in the factory so that the test could be done properly.
Yeah, I would say that those of you that are looking at this as this is a great thing, it was a great thing. I would not expect this to be a routine process. Certainly, if you're buying out a building's worth of boxes from a modular company, hopefully from Signature, you know, yes, it's a good idea to do this, but the level of work and resources that went into doing this, you know, should not be overlooked. If you're looking to include something like this in your quality assurance specification before it leaves the factory, just make sure your budget can accommodate that, because this is not normal.
Yeah, that's a good point, Tony. So yeah, so what we've been doing even moving forward is, you know, we set a budgetary number. Hey, we're building a project that's 60 modules. You know, we'll do 3 in-factory blower door tests, you know, and then we make sure that everyone's on board with that, you know. So we do try to budget some of those numbers in and tell them, here's what you're going to get. You know, if you want more, we can do more, but it's going to be, you know, X amount of dollars. Because again, you can't really do it during working hours. It really needs to be done on off hours or you know, early evening or something like that. So it's just here's just another photo of us ganging 2 modules together, you know, making sure that they're sealed for the blower door test. And Tony, I will love to let you explain this because, you know, this is kind of a little Greek for me, but you know.
That's, yeah, it's no problem. So obviously just the units that were tested, if you're looking in the upper left, you know, that happened to be apartment or unit 301 for, you know, if you're looking at the architectural plans. So this looks like a first test, and the manometer reading at, you know, second from left with the 50.6 and the 4.36. The 4.36 is, I believe, air changes per hour. The middle one is the actual blower door number at 409 CFM at 50. And then the one on the right is the 0.18. That's actually the CFM per square foot, proving the compartmentalization of the apartments. And the limit for this was 0.3. Okay, so you're below 0.2 CFM per square foot, and the logic kind of carries over for the other 4. So 316, you're at 0.2 CFM per square foot, 443 CFM 50, the one in the middle, and then about a little over 4.5 air changes per hour. So the CFM per square foot value for compartmentalization is not, it's challenging, but it's not a huge deal breaker. You know, as you can see, 0.3 CFM per square foot is going to be somewhere around 5 or 6 air changes at the apartment level. So what you're doing is you're testing portions of the building envelope to the exterior and portions of the common walls from apartment to apartment, apartment to corridor. Okay, but that limit for Energy Star and for Phius has to be below 0.3. That limit will change in the future. It's actually going to go down with future versions of Energy Star, but this was a really good sign, getting these values in the factory, even with some, you know, somewhat artificial conditions and things being taped off and things that would normally not be. But this was a really good indication, you know, and a good quality control check. This kind of put everybody at ease. This doesn't necessarily translate to the whole building airtightness test, but it's a good start, an excellent start, I should say. So. Oh, you're muted, Mike.
No, sorry. I said thank you for chiming in. I really appreciate that, Tony. All right, so then yeah, now the modules are shipped to the job site, and then we start to erect the building. And it's the same kind of methodology that we attacked the fabrication, where you know, we subcontracted the set of the job. But it's the same thing. You have to educate the set crews about how important and how vital the air sealing was to the success of this building. You know, it was a very experienced set crew. They were very professional. You know, they're used to, you know, during the erection or the set of these jobs, you know, it's not uncommon for a structural engineer to come in and comment. It's, you know, it's not uncommon for a local building official. It's not uncommon for the mayor to show up and comment to the set crew. But the thought of having an air boss making comments or wanting to verify the set before wanting to verify the air sealing was done before we proceeded, well, that's new, right? That's new to the set crew world. It's something, it's something they never had to adapt to. I thought they did a really good job. Again, certain people on the set crew were assigned roles. One person was doing some taping, one person was doing foaming, someone was doing the sheathing infill. So again, it was definitely a different little process. There were times when they're setting these top stories, they would have to, they would take photos up top and then send them down to the guy below and show them to Tony, hey, does this, is this, satisfactory before we move forward? Is that type of level of care and just acknowledgement that everything was being done correctly.
Yeah, I think the challenge in terms of inspecting the box set as it was happening, they had very, very strict safety rules on this job site. In fact, during during the entire box set process, which lasted, I think it was in 2 phases, right? And it lasted a couple of months.
That's correct. Yeah.
It started in, I think early June and ran through, August.
Yeah.
I was not allowed to step foot in the building unless I had safety harnesses on and OSHA. But, it was really, with all, good intention. I don't think it was done maliciously to kind of keep me out. But you have to recognize the fact that when the boxes are being set, these boxes are finished on the inside. And when you marry 2 boxes together, the only air sealing opportunities that you have when they sit on the podium are the vertical seams on the exterior, the horizontal seam on the top of the boxes before the next boxes go down. A lot of the bottom seam on the marriage joint or the belly band where the 2 boxes join is concealed. You only see that joint at the door openings inside the box. So your ability to rely on the factory air sealing materials, you have to have great faith in that. And we found very early on, because of the irregularities, both in the site construction and just, lumber in general, some of these gaps were as narrow as a 1/4 inch between the boxes, and some of them were about 1.5 inches wide. Some of the sealing materials that were specified were not really doing the job completely. And so it required the set crew to go in and actually inject, some canned expanding foam in the gaps. And then the joints got covered and taped prior to the filler pieces and the fireproof layer, and then the exterior insulation going on. So there was really a concerted effort by the set crew. And you have to appreciate the set crew, and Mike, by all means, stop me, but the set crew is concerned with lifting a very heavy, expensive piece of building and setting it down safely. They are not, like, air sealing is kind of secondary to them. Going home with all of their fingers and limbs and not falling off the building is their primary concern, right? So, to ask the set crew to do this very, very detailed level of air sealing is kind of a big ask and should not be overlooked. Something to have a conversation with the modular company about how well the set crew is prepared and what materials they will have on hand to accomplish it while they're doing this.
Yeah, that's a great point. Because we're even in future jobs, we're prepared if the set crew doesn't feel confident with some of these things that, we would have our own crew up there to just take care of the air sealing. But knowing the experience of this set crew and working with them on past jobs, we knew that they were up for the challenge. But again, once you're living it daily, and you have to be really meticulous about these details. One of the other unique things too about this job was, I don't know if you can tell, but so this building had, from the factory, we put a layer of just 7/16 OSB sheathing on the ends, and then we also installed this greens den glass over the OSB, but we had to stagger the joints because you don't want a building with all these joints alignment. So, that was a little different challenge, trying to coordinate the different breaks in the sheathing so that you didn't have joints going in the same places. And then on top of here, which I'll show you a photo, there's another layer of zip sheathing that was being installed in the field. And then over the zip sheathing, there was another layer of, that's where I think where the exterior cladding went on. But, going back to talking about the set crew, yeah, it's really important to, to make sure that everyone knows what the scope is, that the set crew knows what their scope is, what the factories know what the scope is, who's handing it off and who's taking responsibility of these handoffs, and that's why we just wanted to make sure that, everything was being documented, and we were present at the site all times. That's just another one of those mega beads of air sealing. Yeah, so this is the set crew, and they're going back, and our scope of work had to included, you know, joining the mods together, sealing them, putting the greens, den glass over the sheathing, making sure that all the joints were covered. You know, this was a tough job because there were 2 levels of podium. There was a building section over a crawl space. There was some cantilevers. So there was like a lot of different conditions. It wasn't like one condition fits all. You almost had to have, you know, a detail or a plan for each, you know, for each condition that you're facing out in the field. That was just a picture of them doing some of the air sealing with foam. Oh yeah, so this goes back, this kind of goes back to the joints I was telling you about. You could see like on these, let me go back on, you know, on the long walls of the modular, you could see it's easier for us to put a lot of the green dense glass on in the factory. But when it came to, you know, the sidewalls over here, it's a little problematic because we're trying to fit these windows in and, you know, keep some of the sheathing, the levels of sheathing staggered and everything. So it did present some challenges. It did, you know, it was a slower set process. You know, that was something we learned. We knew the air sealing was going to, you know, was going to be slow down the set a little bit. You know, the additional finish work was a little slower, but again, it was a learning curve for everyone. You know, we've never been through this process before. I feel like we have a much better handle on it moving forward, but you know, everyone just took their time. They knew what the goals were, and it all came together. Let me see if I can find that photo. This is, you know, our scope included another layer of Sega, I think this was Fentrum tape, if I remember, that goes over the sill plate because that adheres to the concrete. So again, you know, not realizing there's a Sega WeGlove tape that's for something and a Sega Fentrum tape that's for something. So for a different condition. And now we recommend these products to clients moving forward. And this was the cantilever condition that we were alluding to earlier.
Yeah. And just for the record, you know, the minute you start recommending tape, everybody defaults to the Huber wood products, you know, zip tape, like that's the be all end all. When you start recommending tape that's, you know, $40 and $50 a roll, they start to look at you a little bit with jaundiced eyes. So, you know, the ace in the hole is sending the Sega rep to the job site and letting him do all the dirty work. But I think it was an easy sell because I think they saw how easy it was to apply. A little bit tedious, and the fact that, you know, we actually had a little bit of a competition, you know, let this stuff set up for a day and try to pull it off, and nobody could rip this stuff off the concrete or anything. They were really impressed with the product, and from then on it was just business as usual with the tape. So
all right, yeah, so this is a good photo of showing all the different levels of exterior that's being done at one time. So on this side of the building, you can see that it looks like we probably just finished putting our layer of a green dense glass on, and then the GC was responsible with the darker zip sheathing on, and they're furring it out, and then you can kind of see they already started to put some of the cladding on the side. And that's just the picture of the building as it was getting finished. And voila, that's it. At the end, you know, I can't speak for the field portions, but, you know, I know all the testing that was done on the modulars went well. This is a rendering of the building. It's been a very successful building for us. And again, it was an interesting process. A lot of collaboration, you know, a lot of things that we learned to move forward. And I mean, to be honest with you, you know, when we're looking at these projects now, we used to look at it in the process of, oh, structural, and then, you know, who the architect is and all this other stuff. I can tell you one of the first things we want to know now when we're getting these jobs is, you know, what type of energy program, who's the energy consultant? Because, you know, the energy community has a lot of influence right now, right? And you know, it's really important to nail down scopes and details early so that these buildings can be successful, you know. And if all that legwork is done early and everyone, you know, has a collaborative spirit and works well together, there's no reason that, you know, this can't be duplicated moving forward.
Yeah, I'll say, you know, Mike had mentioned that they were contracted for this back in 2019. We were contracted as sustainability consultants. We had a CPHC, John Loescher, who provided the energy modeling. This was all done under Stephen Tilley Architects. I was, you know, brought in as the Phius verifier under Stephen to work with John. And it was kind of a team effort. You know, Stephen helped out with some of the air sealing detailing, you know, for the building overall. You know, we all had a part, you know, to play in this. But I will say, when we were brought in, contracts were already signed for this. The work scope was already pretty well defined, and nobody had looked at the programs yet. So in terms of the additional air sealing, the additional level of performance for both mechanical systems, the building performance, even the windows, when we actually started to dig in and do the plan review prior to the boxes hitting the assembly line, you know, ownership was in for a little bit of a awakening, because the project as designed was good, but it was not meeting the Phius modeling requirements. And so it required us to go back, improve the window package, improve the domestic water heating system, the ventilation system. And I will say, the elegant part of this building, other than being modular, is the fact that mechanically it's a very simple building. There's 2 rooftop ventilation systems. It's all primarily ductless air source heat pumps. It's a centralized air source heat pump domestic water heating system. Some small unitary convectors, you know, throughout. It's a very, very simple mechanically designed building, which made the work in the factory, it would have been a nightmare if they had space conditioning ductwork on top of ventilation ductwork to contend with. And that said, when I was brought into this in 2021, having worked on other modular projects, not with Signature, but with other modular multifamily, single family, I was the biggest cynic about being able to do this. But like a moth to a flame, I wanted to do it. I was like, you know, let's prove that this can work. And I had worked with Signature on 2 other single family homes that actually worked out pretty well. They were not certified for any of these programs, but I was introduced by another local builder here in the Hudson Valley in New York, and I was kind of impressed with the product. That being said, when we did the whole building test, remember, these are finished boxes. We did not have the ability to pre-test this building before putting cavity insulation and sheetrock on. That was already done at the factory. We did do a mock-up. We took 1 tower, which was a stack of 4 apartments, 8 boxes. We isolated it, and we did some airtightness testing on that early in the process. We got okay numbers. We did some fog testing and some, you know, smoke chasing and things like that. We got a pretty good idea of what additional work needed to be done at marriage joints and things like that. So right out of the bat, when we got the ability to test the building and do a whole building test, all wagering aside, the very first test came in at about 0.12 CFM per square foot. So that's, if you look at the entire building envelope, floors, walls, and roof, the blower door test at 0.12 CFM per square foot. The Phius target is 0.06 for this building. We were just double. Essentially what that means is we were about 7,000 CFM. Okay, I've tested single family homes that have more than 7,000 CFM. Commercial code requires 0.4. We were already at 0.12. Out of the gate, I was pretty confident that we could fix these leaks. We needed to chase 3,000 CFM of leakage out of this entire building. And through a series of tests and some diagnostics, we were able to you know, we got lucky. we were able to find some big holes. We were able to find some small holes. The final number on this was actually slightly below. What they call a durability test is where you tape off some of the mechanical openings that can be. We were just under 0.6, like 0.053. And then the operational test with those mechanical openings untaped, we were just a little bit above 0.06. So there were four valid attempts to get this building to pass over the course of about 2.5, 3 months. And we got it, and we got it clean, and there you have it. It's certainly earned its certification, that's for sure.
I'm gonna unmute and applaud because Mike, Tony, you brought the extreme ends of the spectrum together for us on a project that is incredibly unique. So we've got tons of questions. I don't know what to say. I'm so excited about this project. It was really fun to learn more about it during our dry runs, and also to be able to go to the factory and see the airtightness testing occurring in real time for projects that aren't passive house, that aren't as challenging as this one. The first thing that comes to mind for me is prefab, and especially modular, often have a connotation around them that they can't be custom, that they're going to be these kind of, you get what you get and you don't get upset mentality. But the ability of SBS, or signature building systems, to customize and be flexible during the process, to stay on weekends to learn some of the new skills that they wanted to learn, makes the first question I'll throw out there before we bring in other co-hosts and the audience is, how many of the techniques that you learned on this project are you now applying as best practices to all the jobs you run through Signature?
No, that's a great question. Yeah, I mean, again, since we're building to a lot of different, stretch codes and Phius standards, we've actually tightened our houses up since this job. We've bought additional product to help, in machinery to help with this process. So if anything, our houses are tighter since we built this one from the things that we've learned during the construction of this. And again, it goes back to the the importance of air sealing. There's like there's a wave of energy coming our way, or energy requirements coming our way, and we'd rather be ahead of it than behind it. So we take it very seriously.
Awesome. Thank you, Mike. Sean, I'm going to pass it off to you to say a few things, and Mark and Ilka, and then we'll open it up.
Yeah, there's lots of questions. We're going to the final 15 for sure. And just to kind of continue with that question, Mike, is, a detail that we don't see in regular construction, which is just even the drywall, the fact that you guys glued on to the studs to help speed up your process. Did that help out with the compartmentalization of each unit? And did it help out with airtightness? I mean, you spoke a lot about different airtightness details, especially the stitching of modules, but I just thought that little process that happens in modular that differs than on-site construction just can help out with compartmentalization of airtightness.
Yeah, I'm not sure actually how that affects the testing, but it does. Our methodology, I think, in general, builds a tighter a tighter house, a tighter project, with just the level of, air leakage, air sealing that we've been doing for years now.
Great. Awesome. All right. We got lots of questions. Let's keep going. I think we're over to Ilka.
Well, I just wanted to comment really quickly too on the scope definition, because that's something that's very different with modular or panelized or prefab construction in general, because all of a sudden, it's not like everyone being on site and kind of working through somewhat of a slower process. This is happening really fast, and we're dealing with like big either panels or boxes, and the scope definition has to be so clear, especially in regards to air sealing. Because if a lot of times we are working with leaders, you know, so to connect all the air barriers from one piece to the other, and that really is dependent on sequencing. So if there is a you know, steel beam flying or a module, everything basically has to be in place in terms of air sealing before that happens, because you know, you're not going to stop any of the modules from flying just to put like a little air sealing membrane down. So I just wanted to comment on that complexity that is, you know, kind of unique to prefab, and you know, it definitely has a part in site build construction, but not as much as this. So communication up front is just so important. So thanks for highlighting that.
Yeah, funny you should say that, because you know, there was an instance even on this job where you know, we're taking such good care in trying to get these boxes airtight into the field, and then the sector is doing the same thing. And then I walked in one of the units, and there was one of the GC subcontractor was cutting a piece of drywall out and took some insulation out to put a foundation hole down in, and they just kind of threw it back in. And I'm like, wait, time out. No, you can't just throw that insulation back in. It has to be like pristine, every cavity. So it was not just, you know, even the GCs and their subs have to learn on these details and methodology onto what they're doing in the field as well.
Strong recognition to that sequencing process that was handled. Delightful to see that come together in this way. And I have to think that the folks that will be enjoying this building have no idea how special this project is. We all realize it here, and super congratulations to all the fine hands and heads that came together.
Thank you.
Thank you.
Absolutely.
Appreciate that.
Yep. And with that, I think we are going to kick it off to Julie Klump. Julie, are you still online? I'm going to take a look. Would you like to unmute and ask your question? Looks like you're here.
Hi, everybody. Well, I had a couple questions, but probably the more important one, because we're in the midst of trying to figure out a passive house modular building that's actually steel and concrete, because it's a high rise. And the struggles are everything that you seem to maybe have as a challenge, but you certainly figured it out. Except for, I mean, as you presented it today. My question is, you know, the big claim on modular is that it saves time. Like, you know, for if you have to relocate people to build a new building, or, you know, tear down a building that somebody's in. Did you guys realize any savings in the schedule from doing modular?
Well, I think you know, one of the advantages is you know, while there's a lot of time that needs to be done on the front end for modular, like all the design, all the materials, like all that stuff needs to be done and solidified way before it goes on into fabrication. Like all the materials have to be at the factory. So the front end of the process may actually be a little slower, but once you go into fabrication, it can speed up, because at the same time, you know, the same time they were putting in the podium for this is we're building the construction. They're not waiting for the podium to be finished. You know, by the time their podium was in, you know, half the building was already done at the factory. So you can kind of gain time as you work in, you know, conjunction with some of the other items that are being done in the field.
I don't
Thanks.
think the schedule was impacted, but I think it was things external to the modular build that sort of, you know, if you wanted to use or classify them as delays, there were some site issues. There were other issues that, you know, added a couple of months to the process. So overall, I don't know that the project got delivered within the time frame that they expected, but I don't think that has much to do with the modular aspect of it.
Good answer. Thank you, Tony. Thanks, Mike. Julie, did you want to respond at all? Or if not, we will jump right on to our next question with our bomb. Our bomb, are you still with us? Would you like to ask your question? If you can't unmute, there you are. Hi, welcome.
Hi, thanks for this amazing presentation. I was able to join a little late, but my first question was, were there any considerations during the design phase for passive solar features? So I think the windows are glazed and highly efficient and low emissivity, but they're still windows, and usually that's the weakest part of the thermal enclosure. So were there any thoughts about doing things like overhangs or shading at certain sides of the building to reduce the need for cooling or heating?
The short answer is not as much as you would think. There were some shading devices on other sides of the buildings, the south and west facing. They did have some trellis type of overhangs, but you don't see the big deep insets for the windows, and mainly because we really didn't have much internal gain because it was senior housing. It was literally, they're just apartments. It's not like an office building or a school or anything where you have to really knock down the solar gain. So they did have shading devices, but it wasn't, I won't classify it as a chore to get the to meet all the annual heating, cooling, and peak heating and cooling requirements.
Great, thank you so much.
And I think the
We are
building
gonna-
was prepped for future solar too. I know the roof loading, it was accounted for future solar in the future.
It's
Great.
zero. It's zero energy ready. We actually built in. We thought in order to get core 2021
Yeah.
certification that there would need to be a solar component, but with the compartmentalization results and with the overall airtightness of the building and a few other planets aligning properly, we were able to actually get core 2021 without the solar. So
Amazing.
Yep.
You guys really knocked it out of the park. We are going to take a quick break and hand it off to Zach for events.
All right, thank you. So I'll do these quick because I know we have lots of questions. So on the Passive House podcast, we have a special episode with Matthew Cutler Welsh, the co-host of the podcast. He is based in New Zealand, and he covers the Passive House Institute New Zealand's conference that just happened, and several speakers from that conference, including Lloyd Alter, who was a keynote at that. So check that out. On Friday, we have Reimagine Buildings How to Decarb, our half-day virtual conference. It's really exciting, lots of signups. It's going to be a great group and of attendees, as well as these fine speakers. We'll be talking about how to reduce operational carbon, embodied carbon, how to electrify everything, access clean energy, retrofits, equitable access to these buildings, affordable housing, like the gamut of how to decarb. So please join us for that on Friday. Next week for our Passive House Accelerator Live Next Up edition of the show, we'll be joined by Shefali Sangvi and Heather McKinstry, who will be speaking about the case for Passive House. So talking about how to land your first decarb project and how to communicate its benefits so that it actually gets built. Then Phius Pro Forum is happening in Rhode Island, Providence, Rhode Island next week. And I think there's still space. So if you are in the area, you should check this out. There you can go for the full 3 days, or also I think they have day passes as well. So this is a great chance to bone up on Passive House as it takes Massachusetts by storm. Building Energy NYC is happening next week in New York on Thursday, October 24th. This is an event by Nessie, really fantastic conference. So that's another one to have on your radar screen, especially if you're in the area. We are about to release, you check your email, and if you're not on our email list, please go to passivehouseaccelerator.com and join the email list so that you can get the link to the new Passive House Accelerator magazine, brand new issue that is about to land in people's inboxes. Passive Resilience Strengthens Community, which is certainly timely given what's been going on in the world with climate impacts. And we are also about to release the Reimagine Buildings Collective. In fact, it is live, so if you want to get a sneak peek, you can check it out. We are going to be formally opening the collective on Friday at the How to Decarb conference, and registrants of the How to Decarb conference will receive the first month free for membership. So there's a little extra incentive for you to join us at the conference and check out the collective. And here is what's inside the collective. For time concerns, I'm not going to go into detail, but we've been working on this for months. We're really excited about it. And that's it. Thank you.
Sorry, that's my turn. Hey, that means we're kind of wrapped up the first hour. We will go into the final 15, which if you look at your clocks is actually going to be the final 9 minutes, because we're a little bit over. So if you do need to leave, come back next week. See you Friday. Big day on Friday. Make sure you're there. It's going to be a fun event to talk about decarb. So again, if you got to go, awesome. Appreciate you joining us today, but we've got 9 more minutes of questions. There's still lots. And I'll turn it over to Shannon to keep going with questions.
Awesome. Thanks, Sean. Our next question is from Bob Wilson, who was here a minute ago. Let's see if he's still here. Looks like it. Hi, Bob.
Yeah, I'm just curious what your forget the land and all of that stuff, what your ended up square cost per construction for square foot was at the end of the day.
It was.
It depends. Does it depend?
Yeah. I don't. There were a lot of mitigating circumstances that were not real hard construction costs. The project, as I am told, all told for 60 units was over $40 million. It was not
Tony,
inexpensive.
those are the questions of, would the team do it again? Were they happy with the results? And altogether, is it a win-win for everybody?
Well, yeah. And then are there cost savings next time? Because now you know what to expect. You've been through the wars together. You've kicked it or knocked it out of the park. And I can't imagine the next one's not going to be streamlined.
Yes. And in addition to that and you've incorporated the dump tax because of that learning curve. And so the dump tax gets reduced next time and will get slowly turned into a dump savings because you've improved things.
The whip marks that I have on my back from ownership and a lot of other, but I'm at the point in the age where I don't care. I kind of like it. What I told them, basically, I told them early on in the project and I told them late in the project, between the GC, between Signature, between the construction management folks, and ownership, the architect, everybody involved. What I told them to do was don't break up the band, because you just spent $40 million for exactly that. You just went to school for $40 million plus dollars. And if you break up the band, the next time you do it, you're going to spend that money all over again. So all I can do is plead, but I can't, you bring the horse to the stream, but you can't get it to drink. So
Tony, that is great advice. I'm going to use that in a few conversations because again, a lot of times you get to a new project and you have to start over and why? Teams worked out well, just copy, repeat. And, again, there might be players, you might have a few different air bosses, but overall there's savings by just keeping the band together.
And just add mentees. All right, our next question up is from Stephanie. Stephanie, are you still here?
I'm here.
Great.
Hi. Great project, everyone. I'm so happy to have this chance to learn about it. I'm gonna keep looking for more opportunities to learn from this team, because you've done a tremendous. It's a gift to everyone here to see this work and to benefit, in incremental ways in our own practices. I had a couple questions. One was construction tech, and the other was about funding. I'll jump to funding. I'm wondering if the project received any NYSERDA or other public funding that incentivized the Passive House certification, and if so, was that a deciding factor in the team pursuing certification? Like, did that push the project kind of over that edge towards success and certification?
I think the commitment to go passive certified was made without a fully understanding of what that meant. That being said, the full gamut of tax credits, financing from city, state, and federal, that everybody was at the table for this project. It was rather complex. I wouldn't be doing the project a service by even trying to explain. But there were literally City of Yonkers, County of Westchester, New York State, HUD. They were all at the table with financing, tax credits. This project did qualify for what was the NYSERDA new construction program, which is now doesn't exist. So we were able to get them in at the top tier incentive level for that. And it did qualify for the IRA tax credits for DOE certification at the prevailing wage level. However, because it's a housing agency and essentially a not-for-profit was set up to be the builder of record, I'm not quite sure if that money or that tax credit will actually see the light of day or do them any benefit. But this was the first project that I've worked on in 20 years that was prevailing wage at any level. And so each dwelling unit was eligible for a $5,000 IRA tax credit for hitting that level of certification. Just don't know whether
But they had already decided to go for certification. It was just a benefit after the fact.
Yep. The housing agency, the head of the housing agency threw that out there and wanted it, and she was hell bent on getting it, and she got it. So
nice. My other question, thank you. My other question was quickly on the sheathing. I saw 3 layers. I'm just wondering if you could explain why that sort of what looks like redundancy was necessary.
Mike, you want to hit? Is Mike still on?
Yeah, I gotta be honest, I really don't know the answer to that question other than that it was in the architect details. So we just had to figure out how many layers we could install at the factory.
So because of the wood, yeah, I'm sorry, Mike. Because it was wood frame construction, the middle layer, the USG, the fire stop layer, was a requirement for fire code. Okay. Otherwise, we would have put the zip sheathing right over the factory applied OSB.
Got it.
Yeah, Stephanie, I think it's like the modular component, the fire rating, and then the cladding.
Yep.
And so sometimes again you get a bit of redundancy. So next time you're like, okay, well, can we reduce a few things or change things up? But as Mike and Tony alluded to, again, is if the materials in the factory, you use that because it's what you're good at, and then you modify things. And so I agree with you. So I think next time there could be some changes to, maybe do some more value engineering. But I wouldn't
recommend the zip product as the primary modular build, simply because you have to truck and lift these boxes.
Yeah, that was one of my questions, Mike, but I'm gonna reach out offline, and Tony, I'm gonna reach out offline with that one.
Thanks, everyone.
Yeah, thank you, Stephanie. Great questions.
The factory didn't receive any tax credits, by the way. So, but if they want to send any our way, we'll gladly take them. But.
Yeah, Michael, you need to find a grant writer just to help out with incentives for education for your team for airtightness stuff and working for that, because I know they're out there.
Yeah,
no, that's a good thought. Thank you.
Yeah, I think we have time for one more. So in the spirit of not repeating folks who've had a chance to ask questions, I'm going to call out Prescott. Hi, Prescott.
Hey, all right.
You get the last question of the day.
Yeah. So it's about air sealing, and I wonder if there was a conversation about an aerosolized air sealer, like an aero barrier. Because I know you said several times, like, they're finished. And I'm like, well, maybe don't finish them. And then you can use the spray. And I know that it gets all over the floor, so maybe you have to plastic wrap the horizontal surfaces. But considering all the crawling around on your hands and knees with a smoke pen, I wonder if that was a conversation of like, let's just spray it.
So to answer your question, aero seal and aero barrier were on the project. We had centralized ventilation systems, and they used the aero seal product to seal up some of the central duct. Okay. But that has nothing to do with the building envelope. That was just to pass one of the Energy Star requirements for centralized exhaust systems. We had to do a pressure test and get a leakage rate on it. So that was one way to do it. I would encourage Passive House Accelerator to reach out to Aero Barrier if you haven't already. I'm sure everybody's, used them. Aero Barrier does not want to be in the situation of emergency fire repair air sealing requirements. They want to be able to go into a raw building or a raw apartment or a raw home, apply their product with minimal setup to protect building components, right? So they don't like to be called, they'll do it, but they don't like to be called into a finished product to air seal to meet something like a Passive House standard. Okay, it's ungodly expensive and time consuming to prep each apartment to do this. Now, that being said, there were two different levels of this building. It was the modular built portion, 4 stories, and there's a podium built, which was like a story and a half below the podium, which was part of the Phius envelope. Aero Barrier, Aero Seal was brought in to seal portions of that below podium section. They also did some stair towers, which was, one was CMU, the other was part of the modular build. The stair tower was actually a hole in some of the modular boxes. So they sealed stair towers, they sealed below podium, and they sealed up some of the apartments that were over the crawl space area. And yeah, if you want to know how a fly feels in flypaper, go into an apartment after they do this, because the stuff, you're walking out with, brown paper on your sneakers, walking down the block. And it's like being tarred and feathered because of the amount of prep work. So it did work. It was effective, but it wasn't the ideal application for the product because it was essentially finished apartments that needed a little bit of air sealing. So.
Okay. Interesting.
Yep.
So I wonder if there's I don't own stock in that particular company, but if they were much less finished when they arrive on site, because that was part of this air sealing strategy in general, like that's pulling on the levers of the whole project, but that could be interesting to see as well.
For sure.
That's where they want to be. They want to be in where you sheathe in the building, you sheathe in, you have your one coated drywall, no finishes, no trim. They go in, they cover the windows, they cover the HVAC outlets, and they aero seal, aero barrier the building to get your compartmentalization or whole building airtightness. That's where they want to be. They don't want to be in the fire drill business where, oh my God, we can't meet Passive House. You got a finished home, finished building, and the setup. It was really, really, it was really difficult for them to do that, but they did it. So.
And every factory is different, as Mike was saying, and some of them deliver more and some of them deliver less. What you guys delivered, obviously, you got to protect those finishes. You really don't want to be, as Tony says, bringing that air barrier in and making that drywall layer your air barrier if you can help it. But you guys hit all of these marks. You needed very little of that. We appreciate how much work you did and how much you shared it with us today. And I really think that Stephanie's comment, what you did today, is a gift to everyone who was here to see it. And I'm excited to rewatch it and share this recording in a week when it comes out, or in a couple of days when it comes out. So Tony, thank you. Mike, thank you. We look forward to having you back when your team is rebooted for the next one.